and inside the heart of every business. And with Amazon Lex, as Andy introduced, we're bringing the power of the platform, the engine that drives Alexa, in the form of automatic speech recognition and natural language understanding to all developers so that you can build conversational, intuitive, and efficient interfaces to your application and your business data. So what I'm going to do here is I'm going to run a demo, and we're going to try and book some travel using Amazon Lex. We're going to build a conversational interface which talks to the service. The audio from my microphone is going to go to the demo backstage, and then we're going to go and try and book some travel. And then after that, we'll take a look at the next level and talk about how it works. So, book a flight to London.
When do you want to travel?
Friday afternoon.
There is a flight leaving at 5 p.m. for $500. Book it?
Book it.
Okay, it's booked.
So that's a very simple example of the type of fluid conversations that you can have with services running on Amazon Lex. So let's take a quick look behind the covers and see how all of this operates. So the very first thing that happens is a recording of my voice gets taken and gets sent up to the Lex service. And there, the recording of the audio gets transcribed using automatic speech recognition, ASR, into text. And then we use powerful, deep learning-based natural language understanding to convert that text and understand the meaning and the intent behind that text. We do that in two ways. The first is we create a custom grammar graph. This allows developers to specify between 5 and 10 sample phrases of the type of questions that they want to be able to answer. And then the service takes those utterances and expands it automatically to over 50 different ways of saying the same thing. That means it's easy for developers to specify all the different ways that a specific question can be asked, and it also improves the quality of the interaction for the end user when they're asking the question. The second thing that we do is we overlay on top of that a knowledge graph. The knowledge graph contains core concepts such as locations and dates and airports, and we can use that to add semantic information on top of the text that's coming from the automatic speech recognition. So here we know that it's not just a flight to London, but we can look at that London, we understand that we're talking about an airport, and we know that that airport is London Heathrow. So after that, we're able to take this information and we're able to map it to an intent. This is what the user, the end user, is trying to get done. And in this case, we're going to go and try and book some travel. And every intent is comprised of a collection of slots of information that we need to be able to go off and fulfill that intent. So the date of travel, the departure time, the origin and the destination, all those sorts of things. And what the service will do is it will start to map the information that's coming through, that's been detected through ASR and NLU, and map them into these slots. So here you can see we've seen that London gets mapped to the destination, London Heathrow. And after that, the service will guide the user intelligently to be able to fill in the rest of the information that we need to go out and fill these slots to fulfill the intent. So the next step is to be able to take this information and build out the response. So we can ask for clarification with the destination.
When do you want to travel?
So that gets sent back to the user, gets converted into lifelike voice with Polly, sent back to the user, and then we wait for a response. And then the cycle just continues again. We take the same input, this time the response, Friday afternoon. We pass it through the automatic speech recognition. We put it through the grammar graph and the knowledge graph with the natural understanding. Here we know that we've got a date, we know the relevant date, and the service understands context. So you can see here that it still knows the intent that the user is trying to fulfill, and that allows you to build sophisticated, multi-step conversational interfaces where you can continue to clarify and guide the user intuitively to what they want to go and fulfill. In addition to that, you can provide personalization and metadata automatically, so you don't have to query the user for information that you already know. So that may be an account number or a login. It also could be, if you have GPS on your mobile device, the location that you're departing from. So here we can use Las Vegas because we know that we're here and fulfill that final origin piece automatically. After that, we can issue a final confirmation.
There is a flight leaving at 5 p.m. for $500. Book it?
Seems like a good deal to me. We accept the confirmation and then we process the intent either automatically or we trigger the business logic to run inside a Lambda function. So you can take your existing Lambda functions and have them triggered through natural language understanding and ASR through Lex. And that's it, boom, the flight is booked. So let's take a look at another similar example. And this time we'll use text interfaces instead of voice. This is the sort of thing you might do through Slack or messaging. And here, let's say that I don't know where I want to travel to yet. So I could ask the service to try and help me to determine where I want to travel. So I could say, well, somewhere with forests and lakes. And the service will return some photos. They look okay, but maybe a city with some great architecture. You can see here we've delivered images that the user can choose from, and then we could allow them to click that and then put them into the flow of booking the flight and the hotels after that. So let's take a look at how this works underneath the hood. So although each of these individual services, Poly and Lex and Recognition, can be used independently, pulling them together allows you to build some really novel, sophisticated, category-defining applications. So here we have a situation where we want to be able to map images to where to help guide the user to where they want to fly to. And so we can take an individual image from the billions that are created every single day, pass that image into Recognition, and have Recognition tell us what is inside the photo. Not just the dimensions or the file type, but we can say that this is a forest and there is a lake in this with some degree of confidence. And you can do that in real time through just uploading the image to the service, or you can apply Recognition to all of the images, millions of them, stored inside buckets inside S3, and they'll be processed in batch. And from there what we can do is we can take all this additional meaning by looking inside these photos, and we can build an index. So we can take all this data, all this metadata, and load it inside a relational database. And then when a new input comes in from a user into Lex, we can parse that using ASR with text recognition, apply our NLU, determine the keywords, and then we can pass those keywords to Lambda to actually go run the query against the new index of images that we have, and then we can return the images that the user wants to see and allow them to use that to spur their imagination for the next destination that they want to travel to. So these are the type of net new functionality that you can add to existing applications and the type of new category-defining applications that you can build with the Amazon AI services. And with that, I'll thank you very much and hand it back to Andy. Thanks a lot.